Thank you for the introduction. Hello, everyone. Good afternoon. So today I will talk about one of our work titled Off-Path Network Traffic Manipulation via a Revitalized ICMP Redirect Attacks. So this is a collaborative work between Tsinghua University, George Mason University, UC Riverside, Zhongguancun Lab, and Beijing University of Post and Telecommunications. So we discover a vulnerability in the ICMP redirect mechanism, which can be misused to bypass the legitimate check over the ICMP error mechanism. And based on this vulnerability, we just discover two type attacks. One is the stealthy remote DOS attack. Another one is network traffic hijacking attacks. And we do experiment to verify the effectiveness of those attacks on the real network and also on the NAT networks. And we also propose some kind of measures to mitigate or defeat those attacks. So first, let me give some background about this ICMP redirect mechanism, which is defined in the RFC 792. So in general, ICMP redirect allowed originators to dynamically update its routing in order to optimize its forwarding path. Now suppose in this example, we have the originator and also wants to send a package to the destination. And first, it will send a package to the default gateway. And the default gateway will forward this packet to the next gateway. And in this example, the next gateway will keep forwarding this package to the destination. So now suppose this default gateway find out the originator and the next gateway, they are in the same network. So originator can directly send this packet to the next gateway instead of first sending to the default gateway. So in this case, default gateway will send a ICMP redirect packet to the originator, tell him, hey, you can use the next gateway as your next hop. So when this originator receives this redirect packet, it will first do a legitimacy check, see, okay, if this is a valid packet. And if it is, originator will update its routing table. So for the future subsequent packet, it will directly use the next gateway as next hop, which will sending this package to the destination. So now let's see what type of this legitimate check will be performed on this originator. So this table shows this ICMP redirect or ICMP error message. So here, just ICMP redirect is just one type of ICMP error message. So this table shows one example of this ICMP error message. And originator, when originator receives this packet, it will conduct two checks. First one, it will check if this message was sent by the default gateway in this example. And we know actually this could be easily spoofed by attacker just by change this the source address to a fake IP address. And a second check actually is related to this the format of ICMP error. Typically, this ICMP error message will contain at least 28 octet or bytes of the original packet, which trigger this ICMP error message. So we see here this for attacker to send this faked ICMP error message, it need to be able to craft this 28 octet data, which can be successfully verified by the originator and accept this. So the basic idea of this attack or this vulnerability is actually we can use this stateless protocol, for example, the UDP, which usually do not remember data has been sent earlier. So attacker can craft this ICMP redirect package, which containing those stateless protocol data to invade those legitimate checks. So in case if this is some modern OS operating system, they may perform some simple checks on this existence of those UDP connections. Actually, attacker can easily trick this originator to set up or establish a connection, UDP connection with this destination. And also, attacker can easily know those information about those UDP socket. So based on this vulnerability, attacker can craft an invasive ICMP redirect message, and then this attacker then can conduct two types of attacks. One is a DOS, denial of service attack. Another one is a network traffic hijacking attack. This DOS attack, so there's an off-path attacker, which is not in the path between this originator and the destination. Actually, it can send out such a malicious ICMP redirect message to cut off this existing connection between the originator and the destination. And in the hijacking attacks, attacker can send this malicious ICMP redirect message, so it can become the next hop to the victim originator. So then it can just manipulate the package from the originator to the destination. Now, first look at some details about this remote DOS attacks. We will use some simple examples to show the idea. So now, suppose we have this victim originator. It could be a web server, or DNS forwarder, or a Tor or relay node. And the destination could be a web client, or this DNS server, or the next hop, a Tor relay node. And first, to be able to launch this attack, attacker will send out a number of this ICMP echo package to the victim originator's network to detect some neighboring node, neighbor host, which resides in the same network with this victim originator. And then this attacker will impersonate the destination to send ICM UDP datagram to the victim originator. The goal of doing this second step is to establish a UDP socket between the victim originator and the destination. After that, these attackers can send a forged redirect message, which, because this attacker knows those information about this UDP socket between this originator and destination, so it can control the material, the data in this redirect message, so it can pass this legitimacy check on this originator. So after that, this victim originator will redirect all its package to the neighbor host. Since this neighbor host is forwarding disabled by default, for all those packages sent to it, it will simply drop it. And then for all this packet from the originator to the destination will be dropped by this neighbor host. So we performed this attack on this Alexa top 1 million website. In total, we set up 6 web client in different cities, 6 different locations. We achieved different number of those vulnerable websites. So in total, we identify more than 43,000 vulnerable websites. And also, this will be account for this about 4.3% of the total web servers. So we figure out, okay, what are reasons for the failures of our attack. So we summarize 4 major reasons for the unreachable website or DNS error. Those are majorly due to this censorship or those gateway ISP, those filtering policies or rules. And also the silent gateway is just for the gateway. They don't just respond to us with their IP address. And also this gateway may have some ingress filtering mechanism, or there's some operating system they are not vulnerable to because they have some specific or customized configuration. They are not vulnerable to our attacks. So we also extend our attack to other scenarios, including the DNS resolver and the Tor relay node. So among this a total number of this almost 2 million DNS resolvers, we found about 54,000 vulnerable DNS resolvers. And also we found like 186 vulnerable Tor relay nodes from a total like 66,500 this Tor relay nodes. Okay, next I will talk about this network traffic hijacking attacks. So this threat model is a little bit different from this DOS attack. DOS attack will be a totally off-the-path attack. This one, actually, we assume this attacker will be within the same network with the victim originators. So then by sending this ICMP redirect packet, attacker can become the next hop of this victim node to forward the package to the destination. So now let's see one example. So in a normal case, user will send a DNS query to the DNS forwarder, which will send this query to the downstream DNS server with the response from this DNS server. This DNS forwarder will send it back to the user. So now for the attacker, they can forward a UDP datagram, which the goal is to establish a UDP socket between the DNS forwarder and the DNS server. And next, this attacker can send this forged redirect messages. This can pass the legitimate check on this DNS forwarder. And then this will be able to redirect all the traffic to the attacker. So now if a user sends a query to this forwarder, the forwarder will send all this query to the attacker. And the attacker can send out this malicious response or replies, which can pollute this DNS cache on this DNS forwarder. And also, this will be provided back to the user. So we conduct this attack in a controlled environment. We control this normal user on the DNS forwarder. So our experiment shows we can successfully conduct these attacks. So for the countermeasure, we propose the countermeasures from 3 angles. First, from network, we can do network change. This is to block crafted ICMP redirects. So nowadays, anonymous, about a quarter of anonymous system allow those forged packets leaving their network. So if we can just enforce this, we can mitigate this attack. And the second one is for protocol change. So we can just improve this legitimate check of this on these ICMP errors. And also on the host change, we can just disable this ICMP redirect mechanism for stateless protocols. Now, conclusion, we uncover a vulnerability in the legitimate check mechanism of ICMP error mechanism. And we show that this can be misused by attacker to launch 2 types of attacks. And also, we propose a countermeasure to mitigate those attacks. That's it. Thank you. I'm happy to take questions.
Thank you.